Hello and welcome to a creative automation YouTube channel. So in this session we will learn about timer. What is timer and how to use timer? Which types of timer instructions are available in TIA portal? So I have already created project and started PLC simulator and downloaded my project. If you don't know how to create a project and use to PLC simulator, then you can refer our last session uploaded in our YouTube channels. So uh, we'll search an instruction palette that which instructions are available for the timer, and inside the timer operation there are instructions available. One is TP, T on, T off, and T on R. So TP means the generate pulse, generate on delay timer, generate off delay timer, and time accumulator. So we'll see each and every instruction step by step. So first of all, we'll start with T on timer. So let's see the operation of T on timer. So this is the T on timer timing diagram. So you can see we'll drag and drop to our network area, T on timer. So it's asking for data block. So we'll see the data block in the next session. So as of now we'll just press OK. And the timer T1 timer block has been added to our network 1 area. So you can see there are four IOs to these instructions. One is in means input, P means PT preset time, Q is your output, and ET means your elapsed time. So we'll see what is the sequence of operation of all this input output and what is the timing diagram for this. T1 means the time on delay timer. So it means the output will be on after some delay. Okay, and this is my trigger pulse. You can see the input pin. So whenever I will give the positive edge here, okay, when I'll give this positive edge trigger, my timer will start. T1 timer will start and timer will start counting here. You can see, right? We have set PT means preset time is 10 seconds. Means I want my output to be on after 10 seconds. So I have set 10 seconds here. So whenever I will give positive trigger at the input pin, at this pin, in pin of your T1 instruction, timer will start counting up to preset time. And when timer will reach at preset time, this point, your output will be on. You can see the output will be start after 10 seconds, and output will keep on until and unless your trigger input is at one condition, means it's on. Once your trigger pulse will fall, output immediately will shut off or turn off and your elapsed time will be 0. You can see here in timing diagram. And when your trigger pulse again will be on here, but your output will not on because your trigger pulse not remain on for 10 seconds. Okay, here there is a mistake. Your ET will start counting here, but again it will drop here because your trigger pulse is not remain on for 10 seconds and your output will be not on. So this is the T on timer. T on timer will work on the rising edge of your input. So it means when rising edge will uh, uh, whenever you will apply rising edge at the input of your timer instruction, your timer will start counting the time, and after preset time output will be on. But the condition is your input trigger input should be 1 at that time. Otherwise, when input pulse will fall, then your output will be 0 and time will get reset. So this is all about timer T on delay timer. We'll see actual practical in our PLC program. So we'll assign here input, which is my I have already created tag for the three timer instructions. So this is my trigger in T on timer. Okay, and my pulse timer. So there is a format you have to write T hash and 10 S for second, M for minute, H for hour. You have to mention, otherwise by default it will take in millisecond. So compulsory you have to assign the S here. So 10 second. And my output is Q 0.0. So I'll assign output also here, T on out, T off out, TP out. And the address of output will be Q 0.0, 0.1, 0.2. Now we'll download our program in PLC simulator and we'll check. So we are working with here simulator, so we have to apply the input physically from the PLC simulator. So we'll open our PLC simulator and there is a sim table. And we'll open and we'll import our PLC tag here. Now make it smaller so we can see both the view of our software. I don't need this one, and I'll make one single screen. So this is my I 0.0. So when I will apply the I 0.0 input, you can see my timer will start counting here. 1 second, 2 second, and after 10 second, you can see in the simulator also, after 10 second, my output Q 0.0 will be on here. Q 0.0 is on, here also on. And when I will remove this pulse, my timer ET will get reset and output will be off. Okay, again we'll check trigger, timer start, after 10 second output will be on. See the output on. When I will remove this trigger, my output should be off and it will get reset elapsed time. When I'll apply here again start input, and before 10 second, if I am removing this input, output will not start and timer will get reset. Okay, so the input should remain high at the input pin compulsory, then and then output will be on after some delay time, whichever you have set in the PT preset time. So this is the function of the T on timer. Now we'll understand what is the T off timer. So this is the T off timer. The T off timer trigger on the falling edge of the input. Okay, and the T off timer, the output will be off after some time. In T on, output will be on after some time, but in T off, output will be off after some time. So output will remain up to PT, means preset time. But there is one another difference. Your T on timer will be on at the rising edge of the input, but T off timer will activate after the falling edge of the trigger input. You can see in the timing diagram, this is my trigger input. When I'm giving 1 here, Okay, this is my rising edge, but I have set PT as a 10 second. My output will be on at the rising timer not on. Here you have to understand, output is on and timer will start counting. So you have to keep in mind that your timer will start at the falling edge of the input, but in the T on side, timer will start at the rising edge of the input. Here, whenever you apply the pulse, your output will be high, but your timer will start counting after the falling edge. See, here you are applying falling edge and your ET will start counting, timer will start counting time, and after the PT, which is 10 seconds, your output will goes off. Here you can see your trigger input is already in the off condition, but output will stay on up to PT. Once 10 seconds get finished, your output should be off and output will be off here. Again, when you apply the positive edge, your output will be on, but when your input gets negative or falling edge here, then your timer will start counting, and after PT, after 10 seconds, your output will be off. So output will remain high up to your preset time. So this is the main difference of the T on and T off. So we'll see in the practical. Again, we'll take T off timer here, drag and drop T off timer here, press OK. I'm giving 10 seconds as a PT. Input is, I have assigned I 0.1 input for the trigger input for T off, and my output is 0.1. Delete the extra instruction, download the program. Okay, again we'll check in simulator because we have not actual PLC connected with our software. Now I am giving 0.1 as the input, activation input for the T. So when I'll apply this at positive trigger, my output will be on. See, my output is on, but timer is not starting, because we already seen the timer will only start after the negative edge of the input side. Negative edge means falling edge. Input will fall from 1 to 0, and then your timer will get start counting up to PT. So this is positive edge now. Now we'll remove the input, means it will detect negative edge here. Removing input. See, now timer will start and output is keep starting, keep in start state. After 10 seconds it will get off. So this is the T off timer. Okay, again I am giving the input. See, at the rising edge, output will be on, but timer will not start. After negative trigger, it will start counting, and after 10 seconds output will be off. In between, if I am giving another pulse, your timer will get reset. It's a totally inverse operation of the T1 timer. Okay, now so the third timer we'll see, which is called the pulse timer, called the TP or PT. So the pulse timer will work on the pulse. So when you will apply the positive edge at the input side, called the trigger input, when we apply the positive edge, your timer output will be on and timer will also get started. So you can see, if I'll draw here the ET diagram, then see, when here you are applying the positive edge, your output will be start and timer will also start counting here. After PT, it is 10 seconds, your output will be off. So this is the pulse timer. Even if you remove the trigger input, still your timer will keep starting, keep counting the time, and output will remain on, and after the preset time your output will be off. So we'll see in the example. Let's take an instruction from the timer operation called the TP. Press OK. This is my 10-second, and the input is I 0.2, and my output is Q 0.2. Download, and we'll check in the simulator. 0.2 is my input. When I'm applying the positive edge here, see, my timer and output both are on at a time, and after the preset time my output will be off irrespective of the input status. See, the timer output is off. Whenever again I will apply the positive edge, and I'll suddenly remove the positive edge, but still my timer is keep counting and output is on, and after 10 seconds my output will be off and timer will get reset. So this is the pulse timer. So whenever you require the timing operation after the pulse trigger, then at that time you can use this type of timer in your application. So timer are very useful, and it's widely used in PLC program because everywhere you have to provide some delay time in your operation. So that time this timer instruction will be used according to their application. Now another instructions called the Tonr. It's called the retentive time on delay timer. So I'm assigning here I 0.3 as a trigger input, and timer is 10 seconds. And here there is one another pin called the reset pin. Why? Because TNR means a retentive timer. It's having one memory, it will retain the counting time. We'll see actual in the live example. So meanwhile I am assigning 0.2 as my reset signal, and there is a output called the Q 0.4. Okay, let's download our program. So this is the extended instruction of the T1 timer. Basically what is the difference between T1 and Tonr? Because in T1, whenever you will remove the input pulse trigger, or whenever you will apply the negative edge, your timer get reset in between. But in Tonr it will hold the time, it will hold the time, it will hold the time. So let's see, we don't have the input here, we'll synchronize. Okay, okay, so Q0 I 0.3 is my input. So when I'm applying here, say after delay 10 seconds my output will be on here. So this is the same function of the Tonr. Now we'll see the add-on features of the Tonr. Whenever I am removing this signal in the Tonr, timer was getting reset, but here you can see the time is in hold condition. Time is stored like 10 seconds. Previously it was 10 seconds, and output is also keep running. So to reset this timer, you have to apply the reset pulse here, positive edge, and then your timer will get reset. Again, when I'm applying positive as the input side, and after some second I'm just removing the positive edge. In Tonr, timer was getting reset, but here you can see timer is stored at the same point where I remove the signal here. Time is 3 seconds, 140 millisecond. Again I'm applying positive edge here, your timer will start at the stopping point. See, and exactly is starting at the 3 seconds and keep counting up to 10 seconds. It will keep counting. But in the T-on side, what happening? See, this is my T-on and I'm applying 0. See, when I'm applying, it start counting, but when I'm removing, again it will get reset. I'm starting, again it getting reset. But in Tonr, it's retaining it's the current time value. Retain means to hold. Okay, it's reset. Again I'm applying positive, removing, positive, removing. See, it keeps counting the time. To reset the time, we have to apply the positive edge at the reset pin. So this is the application where you want to count exact 10 second. If your some pulse are coming and you have to hold the time, like when it came 10 second, 15 second, and after 15 second you want to enable your output, that time Tonr will be used. Or at where some point, like if you want to count the actual running time of your output, at that time you can use the T-on timer, because your output is getting off sometime, getting on sometime. So you want to exactly the on timing of your output, then you can also use the T-on timer. So this is the application of T-on's timer. So for the today timer session, uh, we have covered the 4 timer: T-on timer, T-off timer, TP timer, and Tonr timer. So thank you for watching, and please keep watching and subscribe for the next videos about PLC and SCADAs. Okay, so thank you guys.